Hi, welcome to AristoThink. Today I'm going to address a problem that I can see lots of students making it. It's a problem about the average. Well, we know that we have the simple average when every single number has the same weight as the others, and we have the weighted average when some numbers doesn't have the same weight as others, like your exam. On your exam, you might have like the first exam weight 1 and the second exam weighting twice as much. So what you do? Well, you take your grade on exam 1 plus twice your grade for exam 2 and divide by 3. So this is the weighted average. The weighted average is different. But let's start simple. I want to explain something. Let's suppose you have this. We are going to have the average between the numbers 2, 4, and 10. Well, of course we know this. If you just use a concept of simple average, what happens? Simple. If you just use simple average, it's going to be 2 plus 4 plus 10 divided by 3. So this is 16 divided by 3, 15, 5 in the third. So this is 5 in the third. This is the average, simple average. You know this. But now, come to think about it. Don't tell me you never did this. I did myself. Most of my students, if not all of them, already did as well. Don't tell me that you never tried to do this. Average those two. Average those two. And of course, just keep doing. Average those two. Why not? Doesn't work. You see, 5 and there is 5 and a third. It was supposed to be the same and it's not the same. Well, to make it worse, if you do this on some other moments, it does work. For instance, let's suppose we have 2, 5 and 8. Average those two, 3.5. Average those two, 6.5. Of course, just keep averaging. Why not? 10, 5. It does work. That's it. Simple average. Add everybody and divide by how many numbers you have. 3. 10, 15, 5. It works. And you keep thinking, why, if I just make averages, average doesn't work, and here averages, and average, it works. Well, let me explain you why. The answer is this. It works because this is the average itself. This process only works if this is the average itself. I'm going to explain at the end of the video why exactly is this. But how could you have seen this? First, when you're doing an average problem, I'm going to ask you something. Actually, everything about math goes like this. First, try to make as simple as possible. If it doesn't work, then complicate. But it's like this. We simplify every fraction, don't we? So try to simplify first. Make the problem as simple as possible. And see if you can find a solution. If you can, go for that. Can you see that the distance between 2 and 5, it is 3? And we have the same distance in here as well. So we have 5 as a center, 2 is 3 units to the left, and 8 is 3 units to the right. So we can safely say that it's just like if we have a scale, 5 is the center, we have a weight in here, and a weight there. Exactly the same distance, exactly the same mass. So it's going to be balanced. That is why it works. Now, let's go to another part of the video. That is why this works, okay? But this concept of bringing couples in couples, making averages, don't do this, it is dangerous. I won't say it is wrong, because here it works. If it works, there must be a reason behind, and there is. But you have no idea what is behind that makes this one works. And before that, follow me, follow me. Now, how am I going to explain this is this. I want you to consider those numbers as positions. So we are just placing a mass on top of each position. So I'm going to position a 1 kilogram mass on top of position 2, another 1 kilogram mass on top of position 4, and another 1 kilogram mass on top of position 10. Well, let's go to this part. So we have position 2, 1 kilogram. I have over position 4, another kilogram. And I have over position 10, another kilogram. Now, and this is correct, we can do this safely, always. What? Ignore this for a moment. Those are positions and those are masses in kilograms. Masses must always be the same, okay? Always be the same. Now, ignore this for the moment. Let's simplify this. Remember what I said? Simplify first. So, let's simplify this part. Well, instead of placing a kilogram on top of 2 and another kilogram on position 4, it is exactly the same as positioning both masses on top of position 3. It is exactly the same, always. Now, what is left is 10. Can't I make a couple with 10? No, I cannot make a couple with 10 like I did in here. Why? Because there is nothing left. There is only 10. I already used those 2 to simplify in here. Those 2 kilograms are in here. Can you see? They are in here. Now I'm left with this. Now, how can I average those? Can I just use simple average? Simple average is this. Add everybody, divide by how many numbers? Because all numbers represent the same weight. In here, it's not the same. Can you see that on top of 10 I have what? A kilogram? On top of 3 I have 2 kilograms. Clearly, the weights on top of each number are different. That's why we say we have to make the weighted average. This is on it. The weighted average, which is on top of 3, I just can't just write 3 plus 10. Why? Because 3 has doubled the mass. It has doubled importance. So I have to multiply by these weights. Multiply by 2. You see? Now 10, I only multiply by 1 because it has importance 1. This is doubled importance, agree? It has twice the weight. And now I'm going to divide by the sum. The sum of the weights, 2 and 1, divide by 3. And if you know, this is 6, 16 by 3, 16 by 3 is going to be exactly 5 and a third, just like that. No problems about this? Now, I have been just trying to tell you, imagine those are positions and you're going to put weights on top. I'm going to explain why this doesn't work and why this does work, using the same principle. Now, can you see here, when we take this kilogram and position here, when we take this kilogram, position here, so now we have 2 kilograms, let me take another column, now we have those 2 kilograms in here, they are gone. I simplify those 2. Instead of placing one here, one there, I'm putting both of them at position 3. Now, there are 3 mistakes about averaging to get to 5. The first mistake, this is not a 7. It can never be a 7. Why? Because how can we average, make simple average between 4 and 10 if there is no more 4? Why no more 4? No more 4 because when we average 2 and 4 to make a 3, we use this kilogram put in here, we use this kilogram to put in here. So there is no more 4 and no more 2. There is only 3, position 3, with 2 kilograms. Now, How can I average 4 and 10? 4 is not there anymore. I already used position 4, you see? So first mistake, this is not a 7, it was supposed to be a 10. Second mistake, this is 1 kilogram. It is this one. There is nothing else. What is important about knowing this is 1 kilogram? Because how can it, now the first mistake, this is not a 7, it's a 10. Second mistake, this is 1 kilogram, not 2 kilograms. And the third mistake is this. How can we do simple average, like 3 plus 7, divide by 2 to get 5, if it's not a simple average? Why is not a simple average? It's not a simple average because now we have 2 kilograms on top of 3, and I have 1 kilogram on top of 7. We have 3 kilograms, right? Those 2 in here and this one here. How can we do simple average with 3 and 7, knowing that 7 it is 1 kilogram and that 3 we have 2? Impossible. We can't do this. It is impossible. We cannot do this. And here it works. Why? Because actually on top of 5 we are putting more mass. We're putting actually 2 kilograms. But we have no idea we are doing this. Now it works. Look, because I'm taking this kilogram on position 2 and I'm putting here. I'm taking this kilogram at position 5, the left one, this one, and I'm putting here. So far, we have 2 kilograms in here, agree? Those 2. Now, I'm doing the same. I'm taking the other kilogram with 5, and I'm putting here. I'm taking this kilogram, putting here. So, now I have another 2 kilograms. Now, I can make simple average again. Of course I can make simple average. Why? Because now, can you see? Over 3.5, there are 2 kilograms. Over 6.5, I have 2 kilograms. Now, can you see the difference? Now, they have the same mass. They have the same weight. I can perform simple average in here. It works. And what? But at the end, I have 2 kilograms. Can I just keep adding more masses in here? Yes, I can. Because when I add more masses to the center of mass, this is the center of mass of the system. I'm not changing the center of mass. That is why it works. Because when this number, it is the center of the mass of the system, I can keep adding more and more masses. It's not going to be changed. So it only works because of this. You see? So if we're doing an average problem, and this number is the center of mass of the system, or in other words, if this number, it is the average itself, you can make chunks like this. But if it's not, in this case, you cannot. That is what I wanted to make you think about it. So now you know why sometimes we need to do weighted average as when we have to do some simple average. Just be careful, but at least now you know that you can't just keep applying simple average to everybody. Be careful. Thank you very much. Thank you for asking. Thank you for watching. See you next time. Bye bye.